landscape out here in western Colorado. We've got a lot of different landscapes, don't we? And as you look around here, even right off the side, we've got all these benches and hills and cliffs, and every time there's a change in that topography that you see out there, every time there's a change in the landscape, it's usually due to a change in the geology. And so our job as a geologic mapper is to go out and look at the whole landscape. It takes us about 3 months every summer to go out and walk around the 58 square miles that one of these map areas has. We try to figure out, with all of our training and experience and expertise, what these various pieces and parts are. Is it a gravel that's made out of basalt? Is it a red sandstone that has dinosaur tracks sticking out of the bottom of it? What are these things anyway? And then we try to commit that to a map that would be, again, looking from the sky down to the ground. Now these things are used by all sorts of people. Not only are they beautiful, they look like art in a way. You know, and it's in a way kind of an artistic but realistic representation of what a landscape looks like. And I'm talking right now with the general manager at the Blue Sage Gallery over in Paonia, and I think in February or March they're going to have an exhibit over there about new ways of looking at how to represent the landscape using art, and I'm going to enter a couple of these maps in there just because they're gorgeous. And even as you jump from one map to the other, you see all these really different patterns, and the different patterns all mean something. So it's a really cool way just to look at what the landscape is made of out here. Who uses geologic maps? Well, they're used for all sorts of different things, and really when you think about it, what kind of use of the land that we have that doesn't involve geology? I mean, if you went out to plow your field and there's no geology there, you don't have a field. If your house isn't built on geology, you don't have any place for your house to go. It's up in the air. So we all use geology in one way or another. And these maps are used by people looking for groundwater. They're used by engineers who build roads and who build houses. That are used to show a county what kind of hazards might be out there that have to be accounted for with any kind of growth that wants to happen in the future. The BLM uses these maps for all sorts of things. They use it to figure out where hazards might be at some of their backcountry campgrounds. They use it with their road building as well. So anytime you find out what the land is all about and what it's made out of, then you can start doing different things with it. And it also helps when you've got different types of uses that come together. It helps you make decisions as well. And if you're a rancher or something like that, you may wonder why that part of your pasture always grew really lush and that part didn't. This map may show you why. There may be very different geologic deposits that are all around. And in fact, I was over on Rogers Mesa here a couple of years ago mapping on somebody's land, and we found 2 different kinds of gravels on the property. They had very different physical properties to them. One of them was all irrigated, they had all sorts of stuff growing on it, and one was up a little higher and it was just all covered with weeds. And I talked to the woman who lived at the place. She came from a pioneer family, and she said, "Oh, that's the one that the Indians always talked about being the dead ground." And they called it that because they could never get anything to grow up there. And it turns out to be an old river deposit of the North Fork River. We'll talk about those and look at one really close in just a little bit. But the North Fork River deposits have a lot of sand in them, and if you put water on them, that water goes straight down to the bottom. And anything up near the top, they just can't keep water in it unless there's a fine deposit on the top of it. And so they never could get that one to grow. Everything around it was a basalt gravel that's really broken down a lot. It's got a good amount of clay in it, and it kind of holds the water in when that water is laid to it. So depending on what kind of ground you've got, it reacts real differently to the application of water and to nutrients in the soil and all sorts of things. I can't wait to get up the valley and start seeing the geology at all the vineyards up there, because depending on the type of geology, those plants are going to take in different nutrients, and the same type of wine grapes grown in one type of substrate may come out tasting very different than some on the other substrate. And so that's a cool thing up around Paonia, is we've got all these wineries and they're kind of scattered around on different parts of the landscape, and even a wine from, same type of wine from two different vineyards may taste kind of different. That kind of makes me want to go up and try their wines and see what's going on. Now, I'm being altruistic about this. I'm doing this for a good cause. But once you start looking at it, it's fascinating, just the way the landscape changes and the way that the geology makes up the landscape, and then the ways that we can use the land, or the ways that we have to watch out for the land as well. We want to avoid things like landslides, and we've got evidence going back into the past that tells us that during the glacial period, holy cow, there was a lot of stuff going on out here, and it would have been really exciting to be out here at some of those times. We would have seen gigantic debris slides and mud flows coming all the way down from near the top of Grand Mesa, filling valleys and going miles and miles. There's great big flows racing down the valleys and just covering everything in sight. And it's in a way like they talk about around Mount Rainier and Washington these days. There are old evidences, and they've actually had historical events where the side of the mountain collapses and everything just comes as a big slurry right down the valley. It goes for tens of miles. It goes there into the Olympia, Tumwater area. And so they're big, big geologic hazards. We don't really have that going on today because the glaciers aren't here anymore. But in the past, we've got plenty of evidence that happened, and it happened a lot, and they were big, big events. So we'll talk about that a little bit as well. Cool. So just to get started, let me tell you what we're doing out here as an agency, Colorado Geological Survey. Back in about 1992, there was a program launched by the federal government. It's called State Map. And State Map gave different states in the Union the ability to work with the federal government to make geologic maps. And you might say, well, okay, that's pretty good. Why would we need a geologic map? And we're very specifically mapping at this quadrangle size, this hiking topographic map that you can get. It's really an optimal size for doing geologic maps, for figuring out landscapes, for doing projects, so we can get a lot of users to get a lot out of a map like this. Everything else is much more general.